start dealing with the today's session, friend. And today we are going to bifurcate force into two parts: real force and pseudo force. Okay, so there is something new for you to understand today, friends. So you need to concentrate more on this topic. Will be a 30-35 minutes topic basically, but then we would be discussing the difference between real force and there is another type of force, that is pseudo force, which we have not talked about much earlier. But yes, what we are going to do, we will think about pseudo force also in greater details today. So let's bifurcate it. So the forces can be considered into two parts. The first part is real force. Now what is real force? Let's understand this. Okay. So when I am saying real force in forces, real force, you can see it's a force. Okay. So force which, give me a moment. A force which is produced due to interaction between objects. Again, I repeat, real force is a force which is produced due to interaction between objects. So let's get into more details over here. What it means basically, if it is produced due to interaction between objects, that means it has some specific source and origin, okay, external to the body experiencing that force. Again, what it means, okay. That means in simple words, it can be explained on the basis of fundamental interactions. Now, how many fundamental interactions we have across the nature, in the world, on the earth as of now? We are aware of three fundamental interactions, friends. So the three fundamental interactions are gravitational interaction, the first one. The second interaction is nuclear interaction. And the third one is electromagnetic interaction. So in simple words, if the force originates out of any of these three interactions, either gravitational, nuclear or electromagnetic, then that force will be categorized under real force. So we would be talking about some examples of real forces, but then before we go for some examples, please make a note of this so that we move ahead, and let me know once you're done with it. So in simple words, for real force, it has to come from interactions like gravitational, nuclear and electromagnetic. Okay, so that's when you are going to consider, yeah, so that's when you are going to consider, you know, the forces are real forces, friends. Let's move ahead then. Let's talk about it in greater details. Okay, what are the examples? So these are a few examples which you can, attribute to real forces basically. So the first example, if you want to talk about, here is the first example. You can see, we all know Earth revolves around the sun in circular orbit. Now this is possible because of some force. And which force are we talking about? Gravitational force. Obviously of attraction between sun and earth. So that's why this force, gravitational force, will be considered as real force. Now if you move, you can see a wedge over the wood, a block over the wood, there is a friction being generated. Now this type of friction also comes under, real forces basically. All right. Then if you talk about binding of protons, neutrons in the nucleus, if you observe, the protons and neutrons are there in the nucleus, they don't come out. The moment they start coming out, it becomes nuclear radioactivity. So mostly all the atoms are electrically neutral. So that means there is some force which is, holding the neutrons and protons in the nucleus. And that force is nuclear force, friends. So nuclear force is again an example of real force. So my dear friends, when we jot the examples of real forces, I want you people to quickly note down the slide so that we move forward. So any of these interactions, okay, either gravitational, or nuclear, or you can say electromagnetic. Okay, so you come across a force from any of these interactions, you will consider that force as real force, friends. All right, so hopefully you have noted it down. So let's move ahead. Okay, fine. So then if these are real forces, then the question comes, what's the second type? Okay, so you might have thought about, so forget about what's written here in this case. We will talk it step by step. So when we talk about pseudo force, say example, we are traveling by a bus and suddenly the bus stops and we feel a push forward. We say because of inertia, agreed. But then at your body experiences some force. We are not able to depict the origin of that force. We cannot correlate that force to any of the three interactions. Which three interactions did we talk about? Gravitational, electromagnetic, and nuclear interactions. It's not related to that. But a force acts. So such forces, they get categorized under pseudo forces. So these pseudo forces on the earth act. The only thing is, we scientists, we are not able to link these pseudo forces which act on our body at times to any of the known interactions like gravitational, electromagnetic, or nuclear. And therefore such forces would be categorized under pseudo forces. Now here specifically these points say, you can see, this force cannot be attributed to any of the external source. You cannot link it to any of the interactions like gravitational, nuclear, and electromagnetic. You cannot explain this phenomena using Newton's laws of motion, because according to Newton's laws of motion, only external forces can change the motion of a body. You cannot attribute it. But then one should not forget that the push is being experienced. Simply saying because of inertia is not enough at times. Now we need to get into greater details, friends, isn't it? So we experience the push when the bus stops suddenly due to the inertia. So in order to apply Newton's law to explain this situation, we need to consider an extra force. We cannot attribute this force to any of the known interaction, but we need to consider this extra force in the equation. And this added term, which does not have any real origin, we will call it as pseudo force. So we keep on experiencing pseudo forces in our day-to-day life. So we are going to discuss them in greater details, friends, here onwards, my dear friends. So very important slide. So maybe today we don't discuss pseudo force in greater details. We are creating a base to understand pseudo forces in the coming sessions, basically. So this is an important slide explaining you things about pseudo forces. Please make a note of it before we move ahead. Okay, most of you say done, so let me know. We can move ahead. Okay, so this is how the concept of pseudo force gets introduced, friends. Interesting concept, very interesting concept. You need to concentrate high about how we apply fundamentals related to pseudo forces. But before we actually get into greater details of pseudo forces, that's by tomorrow maybe. But then we can always discuss the three interactions. Okay, the first interaction, you can see the gravitational force. Now between two objects, you can see it's a universal force because it will act between any two objects, sun, moon, moon and earth, earth and sun, and so on. It does not need any intervening medium. There is no medium between sun and earth, but still gravitational force acts. It's a long range force. Obviously it is acting between sun and earth, so it's a long range force, you can see. And obviously it's a force of attraction, mutual attraction. So we know, as per Newton's law of gravitation, every particle will attract other particle with a force, and that force is proportional to the product of the masses. It's not minus over here, it's multiplication. Okay, So product of the masses and inversely proportional to the square of distance between them. When you remove the proportionality sign, you'll have to introduce a constant, and that constant is capital G, friends, which we call it as universal constant. All right, so this is something which you need to know. Okay, so this is the explanation regarding the first type of interactions attributing to real forces, and that is gravitational force, friends. So quick note of this before we move ahead towards the next one. Let me know once you're done with it. Yeah, Amog, you raised your hand. Please let me know what your question is, friend. Amog, you can unmute and speak, no problem.
Sorry, sir, I did it by mistake.
Okay, no issues, no issues. ठीक है, no problem. So let's move ahead then. Hopefully done. Okay. Remember, this force of gravitational interaction is always an attractive force, friends. It won't be repulsive anytime. Between two stones on the earth also you can see there exists gravitational force of attraction. All right, so capital G here in this case stands for universal constant. Why universal constant? Because it is going to be constant throughout the universe. The value will remain same throughout the universe, and therefore we call it as universal constant, friends. So here we can see important thing to be understood regarding gravitational forces. The equation given by gravitational force of earth on a body at a distance r will be given by g m into small m upon r square, where capital M stands for mass of earth, small m stands for mass of a body, and capital R stands for radius of earth, friend. Important thing, this force holds planets together in the solar system, but it is the weakest force of all the three forces which exist in nature. Very interesting. You can see it's the weakest force, but still it holds the entire planets into solar system, friends. Okay. And important thing, it's never repulsive, it's always attractive. This is something which you need to know about gravitational force, friends. So please make a note of this. Once you are done with it, let me know so that we can move ahead. Yeah. Okay. So most of you are done with it. That's what I can assume or presume, you can say. Let's move ahead then. Yeah, the name itself, the second interaction when we talk about uh, is electromagnetic force. The name itself suggests it would be comprising of a combination of electric field and magnetic field, basically. And we all know from magnetic field we generate electric field, and from electric field magnetic field also can be generated. So they are interlinked, and the forces which result out of it would be considered as electromagnetic forces, friends. So a quick note of this slide, a diagram for you, so that we move ahead and I can give you more details about electromagnetic forces then. Once you are done with it, let me know. Yeah, so people, we will move ahead now. Okay, yeah, fine, done. Many of you say that. Okay, so let's have a discussion on electromagnetic force now. So what exactly is electromagnetic force? So one needs to understand is the force between the charged particles. Say for example, two particles have charges q1 and q2 and they are separated by a distance r, and then the force between them can be represented as, you can see, F equal to 1 upon 4 pi epsilon naught k, or it is product of, directly proportional to the product of, the force is directly proportional to the product of the charges, magnitude of the charges, and inversely proportional to square of distance, just like Newton's law of gravitation. But the only, there the constant was capital G. Here the constant is 1 upon 4 pi epsilon naught. this notation in Greek is called as epsilon naught. The spelling for epsilon is EPSILON. Get habituated to these notations now. K stands for dielectric constants. We are going to discuss this constant in greater details in coming sessions for the other chapters which we have in our syllabus. But as of now, just remember the constant is 1 upon 4 pi epsilon naught K, where epsilon naught is a Greek notation representing permittivity of a medium. And what is permittivity? So permittivity is the permission given by the medium for this force, to act between the two charged particles with respect to whatever medium is there between the two particles, charged particles. So the permission granted by the medium is permittivity. The epsilon naught here is representing permittivity of the medium, friends. So this is the force which we are talking about. Okay, so this force is electromagnetic force. The important thing, if the charges are like, then the force would be repulsive. The charges are unlike, then the force will be attractive. So here the force can be attractive or repulsive, unlike gravitational force. In gravitational force, the force is always attractive. It can never be repulsive. Here the force can be either attractive or repulsive, friends. We also, because the equation was given by Coulomb, we also call this as Coulomb force, and it acts along the line joining the charged particles, friends. Okay, as I have said, this force is repulsive for like charges and attractive for unlike charges. Okay, important thing, just like gravitational force, okay, for kilometers it's going to act, thousands, Brazilian times it's going to act. Similarly, electromagnetic force, like gravitational force, is also a long range force. Even if you are talking about electromagnetism over here. So it's a long range force, it's not a short range force, friends. It depends on the intervening medium. Therefore, I said it depends on the permittivity, you can see. It depends on the intervening medium. Gravitational force was not dependent on the intervening medium. So that's the point of difference between electromagnetic force and gravitational force, friends. Yeah. Then if you compare electromagnetic force with gravitational force, the last point easily tells you, it's enormously strong as compared to gravitational force. You might be thinking gravitational force would be stronger. No, it is the weakest force basically. Even if it is holding the planetary system together, still it's the weakest force. And you will find, or it's a reality basically, electromagnetic forces are comparatively more strong as compared to gravitational force. This is something which you need to remember. You need to ascertain, you need to keep it in your mind while studying forces in greater details. So please take a note of it before we move ahead. There are other interactions also which we can think over. Let me know once you are done with it, friends. Yeah, most of you say yes, done. Fine. Okay, no problem. So let's move ahead then. Let's talk about the next type of force, and we call it as nuclear force. Now just imagine, suppose this is the nucleus, we can say. There are protons and neutrons in the nucleus. You all know that very well, okay? You know the structure of atom. There are protons and neutrons. So protons, basically what they should do, they should exert repulsive forces on each other. And these protons should come out of the nucleus. But does that happen? No. That means there is some force which is forcing these protons to overcome the repulsive force and still stay in the family of the nucleus. Such force which holds protons and neutrons together in the nucleus, we will call it as nuclear force strength. So you can see the nuclear force is of two types. The force which I am discussing right now is strong nuclear force. So again I repeat, strong nuclear force is a force which will keep protons and neutrons bound to the nucleus, you can see. So please make a note of it. You can just have a quick click of this diagram also, so that you understand what we are talking about when we are speaking about strong nuclear force. Hopefully you're done with the diagram so that I can show you, some writing statement part of it. So let me know if you're done with it basically, so that we move ahead towards the next slide. Yeah, people, you say yes, so we will move ahead. Again, I repeat for everybody, strong nuclear force is a force which will hold protons and neutrons together in the nucleus. Protons and neutrons together are also called as nucleons because they lie in nucleus. Okay, so let's move ahead. Yeah. So how do we define strong nuclear force? The force which holds the nucleons, that is the protons and neutrons together within the atomic nucleus. Okay, that's how you define strong nuclear force. Remember that it is an attractive force. It's strong enough to overcome the electrostatic repulsion between the protons. That's what we have discussed. Moreover, you can see it's a very short range force. Very short range force. Very short range force. And that's to the order of 10 raised to minus 15 meter. All right. And it's the strongest force of all. And it is responsible for the stability of nucleus. It governs high energy collision phenomena of nucleons. It's a non-central, non-conservative forces. So we will talk about these in greater details in the later sessions. What I mean by saying non-conservative, what I mean by saying non-central. As of now, just make a note of this. We will talk about these two important terms also in the later sessions. Okay, so please make a note of it. And remember one more important thing over here. It's the strongest force. Strong nuclear force is the strongest force available with us on the earth as per the knowledge earth has basically. Okay, hopefully done. Let's move ahead to the next part then. Give me a moment. Yeah, then when I say strong nuclear force, the other thing which will come in our mind is then what's the other type? So other type is weak nuclear force. Now the question is, how is weak nuclear force different from strong nuclear force? So when you think about weak nuclear force, you talk about radioactivity. And when we talk about radioactivity, we all know we talk about the alpha, beta, and gamma rays coming out of the nucleus, isn't it? So in beta decay, beta rays, what happens is there is a phenomena going on called as beta decay. So in beta decay, what happens is nucleus emits an electron and a neutral particle called as neutrino. So electron is emitted in beta decay, and that beta electron makes beta rays negative. And there is a neutral particles also, which is being coming out in the process, and that particle is called as neutrino. So there will be always an interaction between the electron and neutrino. So whatever is the interaction between electron and neutrino which comes out during beta decay, it gives rise to weak nuclear force. So this is again an important statement, how weak nuclear force comes into existence. So this force will act between two elementary particles. And remember one thing, this weak nuclear force is stronger than gravitational force, but very much weaker than strong nuclear and electromagnetic force. That means if I want to put the chronology will tell us, the first force at the bottom will be gravitational force, the weakest force. After gravitational force, the comparatively less weaker force will be weak nuclear force. Then the third number comes for electromagnetic force, and the fourth number comes for strong nuclear force in ascending order. So in questions they ask you which one is the strongest one. So strong nuclear one is the strongest. Which one is the weakest? So the gravitational is the weakest. Second number force, which is the weakest? So weak nuclear force. And the third number is electromagnetic, and finally the most strongest is strong nuclear force. So please make a note of this. Very important slide, friends.